Vitamins and Hormones, Part 4. And in this part, we will see the hormones. And before going to hormone, the general idea of hormones. Hormones are organic compounds internally secreted in the blood of animals by ductless or endocrine glands. These ductless glands are situated in various parts of the body, and hormones are essential or they are required for normal growth, proper metabolism, and also for emotional control. Very minute quantities of hormones can induce and control different types of physiological reactions in the animal body. A slight deficiency or slight excess of the hormone disturbs the proper balance of body and leads to serious defects. Chemically, they belongs to widely different groups of compounds. Thus, adrenaline is a catechol derivative while thyroxine is alpha amino acid derivative. And some of them like insulin and ACTH, adrenocorticotropic hormone, are proteins, while sex hormones are steroids. So, about 80 hormones have been identified so far. Out of these, more than 30 are steroids, and the rest of all are non-steroids. Since they do not resemble chemically, their classification is based on the situation of the gland which produce them or which secretes them and their physiological activity. So, hormones can be broadly classified into steroids and non-steroids. Steroids are further subdivided into sex hormones and adrenal cortical hormones. In sex hormones, female sex hormones and male sex hormones. Male sex hormone is androgen and female sex hormones, these are two, progesterone and estrogen. So this is the classification of hormones. They are also classified depending on the glands which secretes them. So thyroid gland secretes the hormone, and that secretion or hormone is known as thyroxine. And this thyroid gland is situated on each side of Adam's apple. Adrenaline and cortisone, these are the hormones which are secreted by adrenal gland. These adrenal glands are positioned on medulla and the cortex of the kidney. Then this pituitary gland is situated between the brain and roof of the mouth, and pituitary, this is the hormone secreted by pituitary gland. Pancreas is the gland present in stomach, and its secretion is known as insulin. The structure and synthesis of adrenaline. This is the structure of adrenaline, in which one benzene ring, and if we give the number 1, 2, 3, 4, 5, and 6. Then on third and fourth position, hydroxy groups are there. And on first position, CHOH, CH2, NHCS3. This is the structure of adrenaline. So let us see how it has been proved. Adrenaline is an optically active L or minus white crystalline compound secreted by adrenal gland and medulla part of the adrenal gland. Adrenaline is generally administered as its hydrochloride salt. It is active only when it is injected in the body. It contracts blood vessels and thus increase blood pressure. Adrenaline strengthens heartbeats. It is used in the treatment of asthma and to stop hemorrhage. So, the structure of adrenaline is, first of all, let us see analytical evidences for the structure of adrenaline and then we will see synthetic evidences. So, in analytical evidences, first, in analytical evidences, the first point is molecular formula is found to be C9H13O3N. It gives triacetyl derivative, hence it has three OH groups because one OH group accounts for one acetyl derivative. As it gives triacetyl, that means it contains three OH groups. Adrenaline readily dissolves in alkali, that is base, and precipitated by CO2. Therefore, it must be phenol. It further gives the characteristic green color with FeCl3 test. Therefore, it appears to be derivative of catechol. On boiling with aqueous KOH, it gives methylamine, indicating the presence of methyl amino group, that is NHCH3 group. On fusion with KOH, it gives protocatechoic acid. If it is first methylated and then fused with KOH, it gives veratric acid and trimethylamine. This is the structure of veratric acid in which this methoxy and methoxy groups are on the 3 and 4 position and on first position COOH group is there, that is veratric acid, and trimethylamine, this is another side product. Since trimethylamine is obtained, nitrogen atom must be at the end of the side chain. Therefore, the structure may now be written as this OH OH already and this at the end or terminal NHCS3. Then now we have come to the conclusion that the ring is there on and on 3 and 4th position OH groups are there. These OH groups are there. But what is the nature of side chain? One more thing we have confirmed that at the end NHCS3 is there. These three things have been confirmed and one ring is there. But we are not sure about this side chain. On treatment with benzene sulfonyl chloride, adrenaline gives tribenzene sulfonyl derivative. Tribenzene sulfonyl derivative. This on oxidation yields a ketone showing the presence of secondary alcoholic group CHOH in the side chain. That means COH, CHOH. Thus the side chain is either CH2 CHOH NHCH3 or CHOH CH2 NHCH3. Either this OH will be on the first or second carbon. On oxidation, adrenaline gives benzoic acid. To account for this, CHOH group must be attached directly to the benzene ring. Had it been CH2 CHOH, then phenylacetic acid C6H5 CH2COOH would have been obtained on oxidation. Hence, its structure must be CHOH CH2 NHCH3. Adrenaline is optically active due to asymmetric carbon. This C star adrenaline. So, the structure of adrenaline is this one. The structure of adrenaline is confirmed by its synthesis. Stolz and Dakin in 1905 gave the synthesis of adrenaline, and in Stolz and Dakin synthesis of adrenaline, catechol reacts with chloroacetic acid in presence of phosphorus oxychloride POCl3, gives this first acylated intermediate. This is acyl compound COCH2Cl, and further this acyl derivative reacts with methylamine to give this aminomethyl derivative. Aminomethyl derivative. Let us call it as second. And this second intermediate, upon reduction in presence of aluminium amalgam, that is AlHg, mercury, or H2PD, we can reduce this second intermediate by either ways. Either we can use AlHg or H2PD, and we get this final product as adrenaline. So 1, 2, 3, 4. 1 CHOH, CH2 NHCH3, and at third and fourth position OH groups are there. Then second synthetic method is given by Ott and in 1926. Here protocatichoic aldehyde is the starting material, and this protocatichoic aldehyde reacts with hydrogen cyanide to give this cyano derivative. This cyano derivative upon reduction gives amino derivative. What happened? This cyano group have been converted into amino CH2NH2, and this amino derivative further reacts with methyl iodide to give adrenaline as a product. Then in 1918, another synthetic method is given by Nagai, and in this method of synthesis, diacetyl protocatichoic aldehyde is used as starting material. That is, in place of OH, here acetyl derivative of protocatichoic aldehyde is used. So diacetyl protocatichoic aldehyde reacts with nitromethane in presence of alkali strong base potassium hydroxide to give nitro derivative. Here, this nitro derivative further reacts with zinc acetic acid and formaldehyde. We get amino methyl derivative, and this amino methyl derivative upon reaction with hydrochloric acid deprotects these acetyl groups, deprotects these OH groups by acetyl, and we get these two hydroxy groups on the benzene ring, and finally adrenaline adrenaline as a product is obtained. Thank you.